Hello and welcome to the video on Chapter 2. The main topic that we want to talk about in Chapter 2 is something called a frequency distribution. So let's say that we have a set of data, and we'll say this is some quantitative data for now. Maybe we'll deal with the ages of students in a MAT107 class. So let's say I had 40 students in a class and I asked each student how old they are, and they gave me these 40 different responses here. Okay, so this is my data. One of the things I might want to do with this data is organize it into something called a frequency distribution. And in the context of this problem, that means organizing it into different age groups. Now, the technical name for those age groups will be classes. So maybe what we'll do is we'll take this data and we'll sort it into 5 age groups or 5 classes. Now, when we do this, we want each age group or each class to be the same size. So the first thing that we're going to have to do is we're going to have to calculate what we call the class width. And the way we find the class width is we take the maximum minus the minimum and divide by the number of classes. Now these arrows that I have over here pointing up are a reminder that no matter what number comes out of this calculation, whether it's a decimal or a whole number, doesn't matter what it is, I always have to go up to the next highest integer. So in this case, the maximum is 49, the minimum is 17, and I'm going to sort this data into 5 classes. So I'm taking 49 minus 17 divided by 5. So that gives me 32 divided by 5, which is 6.4. Now, normally, if you were rounding, 6.4 would go down to 6. But remember, this is a special calculation where no matter what number comes out of the formula, you have to go up. Even if we got 6 exactly, a whole number, we would still have to take it up to the next highest number, which is 7. So our class width is 7. Now, in order to create this frequency distribution, what we have to do is we have to define our classes, and then we have to count how many data values are in each class. So let's see. The way we create our classes is we create what are known as the class limits. So the lower limit of the first class is always the minimum data value. So I'm starting with 17, that was the minimum if you remember. And then what I do with that 17 is I take my class width, which is 7, and I add it, and that gives me the lower limit of the next class. So 17 plus 7 is 24. That gives me the lower limit of the second class. If I add 7 again, I'll get the lower limit of the next class, which is 31. Add 7 again, I get 38. Add 7 again, I get 45. Now, once I have the lower limits of all my classes, then I can start to get the upper limits. So one of the rules that we want to follow when we create these classes is we don't want there to be any gaps and we don't want there to be any overlap. So if the second class is going to start at 24, the first one will have to end at 23. And if the third class is going to start at 31, the second one will have to end at 30. Notice that if you take that first upper limit, which is 23, and add the class width of 7, you get 30. And if you take that 30 and add the class width again, you get to 37. So you could, once you figure out the first upper limit, just add the class width all the way down. In fact, that's probably what you're going to have to do, at least for the last one, because you can't say, well, the 6th class starts here, so the 5th one has to end at 51. Since there is no 6th class, you wouldn't know that. You would have to take the 44, add the class width of 7, and get the 51 that way. Now, I like to think of these class limits as a rough draft, okay? We don't have the final form of our classes, and the reason why is we still have some gaps here. If we had decimal numbers in our data set, numbers like 23.7, they could fall through the cracks here. Okay, you see the first class goes up to 23, the second class starts at 24, so any decimal numbers between 23 and 24 would fall through the cracks. Same thing would happen with numbers between 30 and 31, 37 and 38. So in order to close those gaps, what we do is we take the lower limits and we subtract 0.5, we take the upper limits, we add 0.5, and we call those the class boundaries. So if I take 17 minus 0.5, that's 16.5. If I take 23 plus 0.5, that's 23.5. So those are the boundaries of my first class. And I can do the same thing for all the other classes. 24 minus 0.5 is 23.5, 30 plus 0.5 is 30.5, and so on. Now, these symbols that are in between those boundaries tell us that the lower boundary is included in the class. That's the less than or equal to sign. The upper limit is not included. That's strictly a less than sign. So the first class goes from 16.5 all the way up to 23.499999. As soon as you get to 23.5, you would bump down to the second class. That class would go from 23.5 all the way up to 30.49999. As soon as you get to 30.5, you would bump down to the third class. So now there's no gaps, now there's no overlap. So these boundaries are more like the final form of our classes. Now, once you've defined the classes, first with the limits and then with the boundaries, you can go back to your data set and you can just count how many numbers are in the first class. Okay, so how many numbers are between 17 and 23, or technically speaking, between 16.5 and 23.5? Well, there were 17 numbers there. How many numbers between 24 and 30, or technically between 23.5 and 30.5? There were 6 numbers there. So you can just count how many numbers are in each of these classes. We call those the frequencies. If you add up the frequencies, you should get the sample size, because everybody's going to be accounted for in one of these classes. So we add these numbers up, we get 40, which was our sample size. We also have something here called relative frequency. This is kind of like a percentage, but it's in decimal form. To get the relative frequency, you're just going to take the frequency for the class, and you're going to divide that by the sample size. So for example, if you take 17 divided by 40, you get the 0.425. So that's like 42.5%. If you take 6 divided by 40, okay, 6 divided by 40 would be 0.150. So that'd be like 15%. And so you can get that relative frequency for all of your classes. If you add those up, you should get 1.00, because that would be 100% of the people accounted for. Now, if you have to round these numbers at all, you might not add up exactly to 1. It might be 0.99 or 1.01. If that happens, no problem. But you shouldn't be way off from 1. There's also something called cumulative frequency, okay, and a cumulative frequency distribution. So this is like a running total. So to create this cumulative frequency distribution, generally what we do is we just list out all the class boundaries here. So remember, the boundary is 16.5, and then 23.5, 30.5, 37.5, 44.5, 51.5. So we just list all those out, and then we ask ourselves how many numbers are less than each of those. So less than 16.5 would be nobody. The minimum was 17. Less than 23.5, well, that's everybody in the first class, so that's 17. Less than 30.5, well, anybody in the second class as well as the first class is less than 30.5, so that would be 23 altogether. How many are less than 37.5? Well, anybody who's in the third class is less than 37.5, as well as anybody in the second class or first class. So you can just add those together and you would have 28. So you can get your cumulative frequency. By the time you get to the last one, how many people are less than 51.5? Well, that should be everybody. Everybody should be accounted for. So your cumulative frequency there should be 40, which is the sample size. Now, sometimes people will make the cumulative frequency distribution separate from the frequency distribution. Sometimes people will just add an extra column on here, and they will call this the cumulative frequency column. And in this case, you would just start with the first class and say, well, there's 17 people there. And then you would go to the second class and say, there's an additional 6 people. Remember, this is like a running total. And then you would go to the third class, there's an additional 5 people, so that would be 28. The next class would have 7 more, so now you're up to 35 altogether. And then the last one has 5, so that would give you 40 altogether. That's everybody. So that's your cumulative frequency. Sometimes it's in a separate distribution, sometimes it's in a column like this. Now, once you have the frequency distribution, then you can start to present that data in different kinds of graphs. Okay, one graph that you can use is a histogram, sometimes referred to as a bar chart. Okay, but you draw a horizontal axis, a vertical axis. We always want to put nice descriptive labels and titles on our axes. So the data, whatever the data is, that's on the horizontal axis, that was ages. And then on the vertical axis, we're going to plot frequencies. Okay, and as far as the title goes, this will be ages of students in our Math 107 class. I use the class boundaries to mark the horizontal axis. So 16.5, 23.5, 30.5, and so on. And then all I do for each class is I just draw a rectangle where the height of the rectangle represents the frequency for that class. So the first class had a frequency of 17, so I draw the first rectangle to a height of 17. The second class had a frequency of 6, so I draw the second rectangle to a height of 6, and then I have all the other rectangles. Now when you look at this histogram, you can see that the ages are predominantly in that younger age group. Okay, that's the feature that kind of stands out when you look at this particular graph. There's another kind of graph called a frequency polygon. This one's very similar to a histogram. It gives you the same information, it just presents it in a different way. For this graph, you're going to make the horizontal, vertical axes. You're going to put the midpoints on the horizontal axis, which again are ages, and you still have frequencies on your vertical axis. And again, a nice descriptive title here, ages of students in Math 107 classes. And then for the midpoint of each class, okay, now how do you find these midpoints? Well, to find the midpoint, you have to take the lower limit plus the upper limit for the class and divide it by 2. Okay, so if we wanted to get the midpoint of the first class, remember our first class up here, which went from 17 to 23? Okay, if I wanted to get the midpoint for the first class, what I would have to do is I would have to take the lower limit 17 plus the upper limit 23 and divide by 2. So if I do that, that's where I get the 20. 17 plus 23 is 40, divided by 2 is 20. So I could do that calculation for each of the classes. Okay, so the next one would be 24 to 30. So 24 plus 30 divided by 2. That's 54 divided by 2. That's where I get the 27. Notice the class width of 7 shows up as the distance between the midpoints. Okay, so you can find the midpoints for each of your classes, lower limit plus upper limit divided by 2. And then above each midpoint, just put a dot where the frequency is. So for the first class, we have that dot at 17. The next class was at 6, and so on with all the others. So we would get our dots here, and then connect those dots with these straight lines. Now to make a true polygon, which is an enclosed figure, what you end up doing is you just take that first dot and you just drop a line down to the horizontal axis, and same thing with the last dot. And so that gives you what we call a frequency polygon. Again, that big peak in the left part of the graph indicates that a lot of people in this Math 107 class are in a younger age group. Another kind of graph is called an ogive curve. This one is related to the cumulative frequency. So what you'll do is you'll put the class boundaries on the horizontal axis, and then instead of frequency on the vertical, you would put cumulative frequency. So you put all your boundaries here, and then if you remember, we said how many people are less than 16.5 years old? Well, that was nobody. So that dot goes to 0. How many people are less than 23.5? Well, that was everybody in the first class. That was 17. Then we said how many people are less than 30.5? Well, that was everybody in the first and second class. So we had 17 plus 6, so 24 altogether, or 23, I should say, altogether is the cumulative frequency for that one. And then you just go ahead and put the rest of the cumulative frequencies and connect those lines with a dot. Now, for any of these graphs, you could also use relative frequencies on the vertical axis instead of frequency. So you could have relative frequency here and just scale the vertical axis in your histogram accordingly. Same thing in the frequency polygon. You could also create what are called cumulative relative frequencies and plot those. That would just be cumulative frequency divided by sample size. And so you would scale the axis accordingly if you did that. A couple of other kinds of graphs that you might make. One is called a stem and leaf plot. For a stem and leaf plot, what we do is we take each of these numbers and we chop off the last digit. Okay, that last digit would be known as the leaf. Whatever was in front of it would be known as the stem. So for example, if we have the number 24, we would chop off the last digit. That would be known as the leaf. And the 2 would be known as the stem. So for each one of the numbers in the data set, you can get the stem and you can get the leaf. Now, if you look at these numbers, we got numbers in the teens, 20s, 30s, 40s. So we're going to have stems of 1, 2, 3, and 4. So what we do to make our stem and leaf plot is we put those stems, 1, 2, 3, and 4, and then we just put all the leaves that would go with that stem. So the number 17 is in this list 4 times. So you got 4 7s here as leaves that go with 1. 18 was in the list, so you got a leaf of 8 that goes with the 1. Okay, and you do that for the 20s, the 30s, the 40s. And what you can see from this graph is that most people in this Math 107 class are in their 20s. A dot plot. To make a dot plot, all you're going to do is draw a number line, and every time a number shows up in the data, you just put a dot. So the number 24 is the first number in the list, so I go find 24 on my number line and I put a dot. And then the number 28 is in the list, so I would go to 28 and I would put a dot. Then 21 is in the list, so I put a dot. If a number shows up a second time, just put another dot above it. If it shows up a third time, put a third dot above that number. And so once you go through the data and put all the dots in, you have what's called a dot plot. So you can kind of see where the dots are concentrated, mostly down here at the lower end of the spectrum, again, indicating younger ages. You could also see which numbers show up a lot, like this number here, which would be 38, has a big stack of dots above it. So that would be a number that shows up quite often in this data. Okay, what if we have qualitative data? Excuse me. If we have qualitative data, maybe what I do with those 40 students who are, maybe what I do with the 40 students who are in the class is not only ask them what their age is, but ask them what their favorite color is. So maybe some students respond with blue, some with red, some with green, some with yellow. Okay, maybe some purple too. So B would be blue, R would be red, G would be green, Y would be yellow, and P would be purple. So here's their 40 responses. Now, if I want to sort this data into a frequency distribution, it's actually a lot easier than the quantitative data. The classes are just the different categories of responses that I might see: blue, green, purple, red, and yellow. And then I just count how many people responded with that particular color. So 11 people blue, 5 people green, 2 people purple, 15 red, 7 yellow. So I can add those frequencies up, I get my sample size of 40 again. And we can create relative frequencies just like before. Okay, frequency divided by the sample size. So 11 divided by 40 would be 0.275, 27.5%. 5 divided by 40 would be 0.125, 12.5%, and so on. And again, those add up to 1.00 here. Now, once I have the frequency distribution, and by the way, this is all that there is to a frequency distribution of qualitative data. Okay, there's no class limits or boundaries to talk about. There's no midpoints. There's no cumulative frequencies. Those things don't really make sense when you're talking about qualitative data. They only make sense when you're working with quantitative data. That's why I said things are a lot simpler when you have qualitative data and you need to make a frequency distribution. Now, once you have this distribution, you can make a graph called a Pareto chart. A Pareto chart is kind of like a histogram because it's got the bars, but the big difference is you're going to sort this data so that your tallest bar goes first and your smallest bar goes last. Okay, so in a Pareto chart, the bars are arranged from tallest to shortest. So even though blue was listed first in my frequency distribution, red had the highest number of responses. So I'm going to put the red bar first, then blue would be second, yellow third, green, and purple. Okay, so red first, blue, yellow, green, then purple. Okay, again, we want nice descriptive labels on our graph every time we make them. These represent people's favorite colors. We're talking about a frequency here, which actually represents a number of students, so that's probably even a better label than frequency. And a nice descriptive title, the favorite colors of MAT107 students. Okay, one other thing that I want to point out to you from chapter 2 is called time series data. Time series data is data that you collect on a regular time interval. So if you check the temperature every day at noon, you're doing that on a daily basis. Or if you're in business, you might tabulate the number of products that you sold at the end of every year. Okay, so let's say we owned like a car dealership or something like that. And every year we tallied up how many cars we sold. So in this case, think of product as cars. So in 2011, we sold 79 cars, 2012, 99 cars, 2013, 105 cars. Okay, every year we sold so many cars. What we can do with that data that we've collected on this regular time interval is we can graph it in what's called a time series graph. Okay, so you put your horizontal axis, that's your time interval. So we're talking about the year 2011, 2012, 2013, all the way up to 2019 here. And then the vertical axis is whatever you counted or measured. In this case, it was the number of products sold, or to be specific, number of cars sold. Now those numbers kind of ranged from the 70s up to the hundreds and something. So notice what I did with my graph here is I just cut a little piece away, so I'm not wasting a lot of space between 0 and 70 where nothing's happening. But then all I do is for each year, I just graph a little point that tells me how many products I sold. So in 2011, we sold 79 of them. So I put a dot there. And then for each year, I put a dot at the appropriate place, and I connect those with these straight lines. Now, what you look for in a time series graph is you look for trends, or you look for breaks in the trends. So notice here, things were trending upward for a while, first maybe 5 years or so that we were in business. Then all of a sudden, we had this big drop in our sales. And then things kind of picked up where they left off and continued to increase. So it looks like somewhere around 2016, we had a big drop. So you might look back at this and say, well, what happened in 2016? You might say, oh, that was the year that our top salesperson retired and we were kind of short-staffed, so maybe that's what happened. Or maybe you would say, well, that was the year we tried this new advertising campaign. Apparently it didn't work. So after we scrapped it and went back to the old way of advertising, things, started selling again. So you can just look for those breaks in the trends and say, well, what happened there? And maybe learn something. Okay, so that's an overview of chapter 2. That's some of the highlights that are in chapter 2. There's a lot more in the book. Make sure you read that. Make sure you go through the chapter thoroughly. Okay, but I at least wanted to present these highlights to you. Thank you for your time. In the next video, we'll be moving on to chapter 3.